Let's continue with our next topic, binomial distribution. I'll start with a simple example so that you understand concept and also application of binomial distribution very easily. So let me take an example of tossing a coin. So when we toss a coin, in the sample space there will be two outcomes. One is head and other is tail. So when we toss a coin, we know that either head will appear or tail will appear. Suppose I am interested in getting head. So this is my success. So whenever head appears, that I will consider as my success. Now what is the probability of my success? Definitely we all know it's 1 by 2 or 0.5, because when we toss a coin, the probability of getting head is 0.5. Suppose I am interested in something more, like I will not restrict for tossing only one time. Suppose I do this experiment repeatedly. Say for example, I want to do the same experiment 7 times. And I have defined that getting head is my success. And if I want to calculate what is the probability that out of these 7 times, what is the probability that 5 times I will win. So what is the probability that 5 times I will get head? Okay, if I am interested in this type of questions. Here binomial distribution will help us. The probability mass function of binomial distribution is NCX P to the power x and Q to the power n minus x. So this is the probability mass function of binomial distribution. This will give you probability of exactly x success out of n trials. So if we do an experiment n times, if I want to calculate probability of x success, then I can use this. So in our example, we are tossing the coin 7 times. That means my n is 7. 7 times I am doing this experiment. And I am interested in 5 success. So my x is 5 here. And what is this small p? Small p is the probability of success in only one trial. Instead of doing 7 times, if I do only one time, what is the probability? The probability of my success. That already we have discussed. It is 0.5. So my p value will be 0.5. And what is q? Q is probability of failure. So it is very easy to calculate. Whenever you have p, q can be calculated with the help of the concept of complement, 1 minus p. So q will be equal to 1 minus 0.5 here, which is also 0.5. So now we have all the values required, and if we can very easily calculate this probability. Let me do this one for you. It is 7c5, 0.5 power 5, x value is 5, and another q value power n minus x. N is 7 and x is 5. So 7 minus 5 is 2. And you can use your scientific calculator to calculate this, or if you want to know it how to calculate manually, 7c5. So we all know NCX formula. NCX formula is n factorial divided by x factorial into n minus x factorial. So this will be 7 factorial divided by 5 factorial, and 7 minus 5 is 2 factorial multiplied by 0.5 power 5 multiplied by 0.5 power 2. So this calculation, when you do, you know that 7c5 will be 21, and multiplied by these two values will give you approximately 0.164. That means almost 16% chance is there that 5 times I'll win this game. 7 times we are playing, and 5 times, the probability of 5 times winning is 0.164. So hope you have understood how when to apply binomial distribution, and PMF. Once you have the PMF, you can prepare the probability distribution table also for this, because whenever you play a game 7 times, it's not necessary that you will win 5 times always. There is a possibility that you will not win at all. So your success will be 0 times, or you may win only 1 time, or you may win 2 times, you may win 3 times. So all the possibilities are there. X values, if you consider X as the success, 0 success you may have, 1 success, 2, 3, 4, 5, 6, 7. And you can calculate all these probabilities by giving different values for X in the PMF. So for example, 7, see 5 success of 5 success we have already calculated. It is 0.164. Suppose you want to know what is the probability that you will have 3 success. So instead of 5 here, you have to replace it by 3. Just you have to replace the value of X. So in this power also, this will, instead of 5, this will become 3, and power also, instead of 5 it will become 3, and this the other power 7 minus 3 will be 4. So if you want to calculate this, and 7C3, we know that it's 35, and the final value will be 0.2734. So 0.2734 will be the probability of 3 success out of 7. Okay. Similarly, by changing the values of X in the same formula, what is there in the box, you can replace X by these values, X equal to 0, 1, 2, 3, 4, 6, 7, and you can fill this table. So once you have done this, your probability distribution table will be ready for the binomial distribution. And you can also observe that if you add all these values, the sum of the probabilities will be equal to 1. And to calculate the mean, you don't have to use the general formula what we discussed in our last topic. The mean of binomial distribution will always be equal to n into p. That I have given it in this slide. Mean formula is n into p. In this example, our n value is 7 and p value is 0.5. So the mean of this binomial distribution will be 3.5. And similarly, you can find the variance. Variance formula will be n into p into q. So n into p already we got 3.5, and q also we will multiply to this. So this will give you the variance. So once maybe approximately it is 1.75, and once you have the variance, you already know that standard deviation is just the square root of variance. So standard deviation will be square root of 1.75. So what I hope you have understood that binomial distribution PMF is NCX p power x q power n minus x, and this will give you the probability of x success in n trials, where p is the probability of success in 1 trial and q is 1 minus p, which is probability of failure. Okay. Let us have one more example, and if you have understood completely, you can skip it also. So I'll take an example of this question, what I have written in the slide. The probability that a pen manufactured by a company will be defective is 0.1. If 12 such pens are selected, find the probability that exactly 2 will be defective, none will be defective, at most 3 will be defective, at least 2 will be defective. So 4 different questions are given, and we have to just understand what is n, and what is p, and what is x. So what's happening here? We are having a lot of pens, and the probability that one pen, if I pick one pen, the probability that it is defective is 0.1. So my n, I am doing this experiment 12 times because 12 pens I am selecting. So 12 pens I am selecting, and my X is number of defective pens, because this is the uh, random variable what we are discussing about, defective pens. So how many are defective? The number of defective out of these 12 pens. I have selected 12 pens and my success is getting a defective pen. So n is 12 and x is number of defective pens, and p is given the probability of defective. If I select one pen, the probability that it is defective is 0.1. So if P is 0.1, what will be Q? Q will be 1 minus P. 1 minus 0.1 is 0.9. Okay. Now you can take, you will be ready with your PMF. What is it? P of x is NCX. We know that n is 12. So 12CX P power 0.1 power x, and Q power 0.9 power 12 minus x. And let me take the first question. The probability of exactly 2 defective. That means x value is 2. I have to calculate P of 2. So it is 12C2 0.1 power 2 multiplied by 0.9 power 12 minus 2, which is 10. So this you can calculate, and the value of this will be 0.2301. So the probability that out of 12 pens, the probability that 2 pens will be defective is 0.2301. Approximately 23% chance is there that 2 pens will be defective out of 12 pens selected. Let me take the second question. None of them will be defective. None of them. So no pen will be defective. All the pens will be good. So probability of 0 defective. So x is the number of defective and x is 0 here. So this will be 12C0, 0.1 power 0, and 0.9 power 12 minus 0 is 12, which is equal to 0.2824. Okay. And now the question is, at most 3 will be defective. What does it mean? At most 3. That means there cannot be more than 3 defective pens. Maximum 3 defective pens will be there. So it is the probability of x less than or equal to 3. The defective pens should be either 3 or lesser than that. It cannot be more than 3. So probability of x less than or equal to 3 means there can be 0, because x values that are less than 3. P of 0 plus P of 1 plus P of 2 plus P of 3. So all the 4 probabilities you can calculate separately and you can add them one by one, and its answer will be 0.9743. And the last question, at least 2 will be defective. At least 2 will be defective. So what does it mean? Minimum 2 pens will be defective. So how do you calculate this? Minimum 2 will be defective. Probability that x is greater than or equal to 2. Minimum 2, that means it can be more than 2. So what are the values, different values x will take? X greater than or equal to 2 means it is 2. It can be 3 also, it can be 4 also, it can be 5 also, it can be 6, 7, 8, 9, 10, 11, 12. So too much calculation. Instead of doing this many calculation, we can use one more concept of complement. Probability of x greater than or equal to 2 is 1 minus probability of its complement, x less than 2. Greater than or equal to 2, complement is x less than 2. Okay. So this will be 1 minus, what are all the values? X less than 2. It is 0 and 1. Only 2 values. Calculation will be very simple. And this you can calculate this 12C 0, 0.1 power 0, 0.9 power 12, and P of 1 is 12C 1, 0.1 power 1, and 0.9 power 12 minus 1 is 11. So you can calculate and cross check that. the final answer will be 0.3409. So hope you understood the application of binomial distribution, and you can have practice with different examples. I have written some of them. Let me explain this. The number of telephone lines busy at an instant of time is a binomial variant with probability 0.2. That means the x is the number of lines busy, and the probability that one line will be busy is 0.2. Immediately you can get to know what is q. Q is 1 minus 0.2, which is 0.8, and you are choosing 10 lines, so n will be 10. So what will be your p of x? It is 10cx 0.2 power x multiplied by 0.8 power 10 minus x. And two problems are there. In first problem, 5 lines are busy, so you can put x equal to 5 and calculate this. And in the second question, all lines are busy, all 10 out of 10, so I can put x equal to 10 and calculate.